All right, so welcome back. So we're going to learn order of operations um, that include fractions, but we'll also have mixed numbers and exponents. Okay, so what we want to do for this particular problem, notice that we're going to do everything in the parentheses first. And notice that we have a negative sign right here. Okay, and then we have that next to a positive. So what we're going to do is, remember that is a positive times a negative, okay? So we're going to simplify that as 4 over 15 minus 5 over 3. And this means we are going to write 2/5 times 2/5. Remember that that's 2/5 times itself twice because the exponent is 2. Okay, it does not mean 2 times 2 and then 5 times 2. Okay? So what we're going to do is, off to the side, we're going to do what's inside the parentheses first, right here. And then we're also going to multiply this. Okay? So we'll do this off to the side. So 4/15 minus 5 over 3. And if we do the butterfly method, okay, so that's going to equal 4 times 3, and then we're subtracting the two fractions, so we're going to put a subtraction, and we're going to multiply these two together, so that's going to be 15 times 5, all over 15 times 3. Okay? So we set it up just like that. Okay, and then now we're going to do 4 times 3. Well, that is 12, right? Minus, and then 15 times 5 is 75. And then 15 times 3 is 45. And then if you do 12 minus 75, we're going to get minus 63 over 45. Okay? And if we divide both of these numbers by 9, we can actually get a reduced fraction here. So 63 divided by 9 is going to be -7. Don't forget the negative. Okay? And if we take 45 and divide that by 9, we actually get 5. So we can go ahead now and put -7 over 5 minus, and then don't forget, we can go ahead and multiply these two together straight across. Okay? So that's going to equal 2 times 2 is 4, 5 times 5 is 25. Okay? All right, so now we can go ahead and subtract the two fractions, right? In other words, we're going to be doing this right here, and that would be the last thing to do. Okay? So let's see what happens when we subtract these two fractions. We can just go ahead and use the butterfly method. So we're going to do -7 times 25. Okay, so that's going to equal -7 times 25 minus, and then we're going to do 5 times 4. Whoops. Or 4 times 5. All over, and then the bottom two denominators get multiplied, so 5 times 25. All right, so So now when we do this, okay, we're going to do 7 times 25, which is going to be negative 175. Remember, there's a negative 7 here. So negative 175. 4 times 5 is 20. All over 5 times 25 is 125. Okay, so when we go ahead and do that, minus 175 minus 20 is negative 195 all over 125. So remember, if you have minus 175 and you're taking away 20 more, just add the two numbers and keep the negative sign. So it'll be minus 195. And if we divide both of these by 5, okay, then negative 195 divided by 5 is going to be 39, negative 39. And 125 divided by 5 is 25. Okay, so the answer is going to be this. That's your improper fraction form. Okay, and remember, if you wanted to convert this to a mixed number, okay, so I'm going to put or, and then just put a little arrow, then it'll equivalent to a negative, because there's a negative fraction. You would take 39 and divide it by 25. Well, 25 goes into 39 one time, and that's the number off to the side. All right, and then there's going to be 14 left over, because if 25 goes into 39 once, then you need 14 more to make 39, and that's going to be over the original denominator. And right, and the whole fraction is negative, so that's why I put the negative there. So either answer is fine, okay? You can just leave it in improper fraction form, okay? Only convert it to a mixed number if it's asked, during a test or, whatever format it wants. But both answers are equivalent, okay? All right, so let's do another example. Okay, and let's do mixed numbers now. All right. Here we have 3 mixed numbers, okay? Before we do anything, we're going to convert these to improper fractions, okay? Because every time you have a mixed number, it's always going to it's always going to change to an improper fraction. And an improper fraction is when you have the top number bigger than the bottom number. So the numerator is going to be greater than the denominator. And we do that by taking the whole number, which is 2, and then we're going to multiply it by the denominator, which is 3. Then we're going to add the numerator, which is 1. Okay? And when you do that, you're going to get 2 times 3 is 6, plus 1 is 7, all over the original denominator, which is 3. Okay? And we're just going to repeat that for every fraction. Okay? So for the middle one, we have, when we have we're just going to ignore that negative, so just do 1 times 2, so the number 1 off to the side times 2, which is the denominator, plus 1, okay? And when we do that, that's going to equal 1 times 2 is 2, plus 1 is 3, over the original denominator, which is 2, okay? And then the other one, the third mixed number, we can just take the number 3, multiply it by the denominator 3, and add the numerator, that's 1. 3 times 3 is 9, plus 1 is 10, okay? 10 over the original denominator, which is 3, okay? So now we have all of those mixed numbers converted to improper fractions. It's a little bit easier to see or to handle. And when we multiply and divide mixed numbers, we have to change them anyway. okay? So that's why I think it's a good idea to get into that habit of converting all mixed numbers to improper fractions. Because when you have division and multiplication of mixed numbers, you have to do that anyway. All right? When you add or subtract mixed numbers, you don't have to change them, but it's easier if you do, in most cases, okay? So I just like to get into that habit because, in my experience, a lot of the times they're a little bit easier for students to work with. Now, when we do PEMDAS, okay, we are going to do, remember if you have PEMDAS, right? Okay, after you clear parentheses and exponents, now we look for multiplication and division. And you notice that we do have a multiplication here, okay? So you do those first according to the order of operations with PEMDAS, okay? So if we do that off to the side, then if you have 3 halves and you're multiplying it by 10 over 3, it'll be a good idea to see if you can cross cancel anything and before you multiply top to top, bottom to bottom. Look at the 3's. 3's goes into 3 once, 3 goes into 3 once. So we can cross cancel the 3's. And then you can also cross cancel the 2 and the 10. Okay? So 2 divided by 2 is 1. 10 divided by 2 is 5. So now you just have 1 times 5 and 1 times 1. So the numbers are a lot smaller. Okay? So remember you have 1 times 5 over 1 times 1, which we all know is 5 over 1. 5 divided by 1 is just 5. Okay? So then you just have 7/3 take away 5. And we're going to write that as 5 over 1. Okay? So let's see what we get when we do the butterfly method. Okay? So that's going to equal 7 times 1. Since we're subtracting the 2 fractions, we're going to put a subtraction sign. Then we're going to multiply these 2 together, which is going to be 5 times 3, and that's all over. The 2 denominators get multiplied together, which is 3 times 1. Okay, so 7 times 1 is 7. 5 times 3 is 15. Okay, and whoops. And that's going to be over 3, because 3 times 1 is 3. All right. And then now, we just go ahead and perform the operation in the numerator. So we have 7 take away 15, which is going to give you -8, because you're subtracting more than what you started with. And that's going to be over 3. And that doesn't reduce. So this would be your final answer, -8/3. Okay, if you wanted to convert that to a mixed number, then it's going to be negative, okay, because the fraction's negative. And then you figure out how many 3's go into 8 evenly. Well, let's see, 1 3, 2 3's would be 6, so we're going to say 2, okay, and then there's going to be 2 more to make 8, so there's going to be 2 left over the original denominator. Okay, any one of those answers is acceptable. Okay, so let's do another one. Let's see. -1. All right. So when you do order of operations, we should go ahead and do everything inside the parentheses first, okay? And when we do that, if we convert 2 1/3 to an improper fraction, if we convert the 1 1/2 to an improper fraction, this will be a lot easier, okay? So remember, we can kind of do this, we take the 2 off to the side, okay? So remember, when we do that, okay, take the 2 and then multiply it by the 3, and then we're going to add the 1. So when you do that, that's just going to give you 2 times 3 is 6, plus 1 is 7 over 3. okay? And then we just go ahead and convert the other fraction, okay? Remember, you take the number off to the side, times it by 2, go ahead and add your numerator, and then now that's just going to equal 1 times 2 is 2, plus 1 is 3, all over 2, times, and let's convert this one over as well. Okay, we may as well do that. Take the side number, which is 3, multiply it by the denominator, which is also 3, and then we add the numerator, which is 1. So 3 times 3 is 9, plus 1 is 10, all over 3. So now we converted all our mixed numbers to improper fractions. Now we follow order of operations. Again, we're going to do this. Okay, so we'll do this off to the side. This just becomes a simple butterfly method. Okay, so we're going to write 7 times 2, and then we're subtracting 3 times 3, all over 3 times 2, and that's going to be, let's multiply all these together. 7 times 2 is 14, 3 times 3 is 9, 3 times 2 is 6, okay, and when we do that, okay, 14 minus 9 is going to give me 5 over 6. So we're going to replace this with 5, 5 over 6. And that's going to be multiplied by 10 over 3. Okay? All right. Before we multiply these, let's see if we can cross-cancel anything, because it'll make it a little easier. You notice that the 5 and the 3 don't cancel, but 6 and 10 can be divisible by 2. So 6 divided by 2 is going to be 3, and then 10 divided by 2 is going to be 5. All right? So, and then we can just go ahead and multiply 5 times 5 and 3 times 3, so it'll be a little easier. 5 times 5, again, is 25. Okay, so let me write that over here. And then 3 times 3 is 9. So the answer is going to be 25 over 9. Or if you want to convert it to a mixed number, 9 goes into 25 2 times. Okay, and that's 18, right? 9, 18, and then how many more to get to 25? Well, you need 7 more, because that's the remainder, and that goes on top, over the original denominator 9. Okay? So either one of those answers would be correct. All right. Let's go ahead and do another example. All right. So here we'll do more mixed numbers. Okay. I'm going to multiply that by this. Okay, so I got 3 1/4 minus 1 2/3 in parentheses times, in parentheses, 5 1/3 minus 2 1/2. So it would be a good idea if we convert every one of these mixed numbers to an improper fraction. So we'll do the first one, okay? So we'll have 3 times 4 plus the numerator 1. Can you see how I did that? Okay. And that's going to give you 3 times 4 is 12, plus 1 is 13 over the original denominator 4. Okay. And we should probably do the next one. Okay, so we have 1 times the denominator 3 plus 2, which is the numerator. And when we do that, 1 times 3 is 3, plus 2 is 5, all over 3. Okay? And then we just move on to the next one. Okay, remember this is for this one. The next one, which is this guy, take the number 5, multiply it by the denominator 3, add the numerator 1. And that's going to give you 3 times 5 is 15 plus 1 is 16 over the original denominator 3. And then the last one, we take the number off to the side, which is 2, multiply by the denominator 2, add the numerator 1. This will give you 2 times 2 is 4, plus 1 is 5, all over 2. And now we've converted everything over. And then just do what's inside the parentheses from left to right. I'm going to start with these two. Okay, and let's go ahead and do the butterfly method right here. Okay, so that's going to give us 13 times 3, take away, because we're subtracting the two fractions, and then we're going to do 5 times 4. Okay, divide it by the two denominators multiplied together, which is 4 times 3. All right, and let's see what we get when we do that. All right, so okay, so 13 times 3 is going to be 39. 5 times 4 is 20, and then 4 times 3 is 12. Okay, so 39 minus 20 is going to be 19 over 12. Okay, and then we're going to do the butterfly method for the second group of fractions. Okay, and we could just do that right here. All right, and then we're just going to write that as 16 times 2, take away 3 times 5, or 5 times 3, all over the two denominators that multiply together, which is 3 times 2. And then, of course, we can go ahead and finish this off. 16 times 2 is going to be 32, minus 5 times 3 is 15, 3 times 2 is 6. When you do 32 minus 15, we should get 17 over 6. And then now it's a matter of multiplying the two fractions. Okay, and again, when you do that, you just multiply straight across. Okay, there's no cross canceling here, so we're just going to have to deal with the two numbers, the bigger numbers. 17 times 19 is 323 over, and then 12 times 6 is going to be 72, and that doesn't reduce, so that would be the final answer. Or if you want to convert this to a mixed number, then you figure out how many 72s go into 323. All right, and if you do the arithmetic, 72 goes into 323 4 whole times. Okay, and that's going to give you 288, and then how many more to get to 323? It ends up being 35 more, so that's the remainder over the original denominator, which is 72. Okay, so either one of those answers is acceptable. Okay, all right, I just have one more. All right, and just a simple one here. Okay, so we'll finish off by doing this last example, and we have 5/6 divided by 2/3 to the second power. So if you write down PEMDAS, okay, and you follow the order of operations, we should clear the parentheses first. So this can be written as Okay, let me just copy it. It's 2/3 times 2/3, because the exponent is telling you to multiply the base. Okay, so remember, the 2/3 is the base, and this exponent here, okay, is telling you to multiply this 2 times. So that's why I wrote 2/3 twice, okay? And when you do that, if you just multiply it straight across, okay, then you have 5/6 divided by 2 times 2 is 4, 3 times 3 is 9, and then you have 5/6 divided by 4/9. Okay, so if you remember the rules of division, we keep the first fraction, change the division to multiplication, and flip or do the reciprocal of the second fraction. So when you do that, you have 5/6, because we're keeping the first fraction the same, okay, and then we're changing the division to multiplication, all right, and then we're going to flip the second fraction, which is 9/4. So and now this becomes a multiplication of fractions. Okay, before I multiply straight across, I want to see if anything cross cancels to make these numbers a little smaller, because if you do that, then you don't have to reduce at the end. Okay, notice the 5 and the 4 is not reducible. There's nothing that divides into both of those numbers other than 1, which won't really help us here. But if you look at the 6 and 9, both of those numbers are divisible by 3. So we're going to divide 9 by 3, and it goes into it 3 times. Okay? And 3 goes into 6 2 times. So now we're just going to have, okay, when we multiply 5 times 3 and 2 times 4. Okay? And that's what we have. Okay, and this will make the fraction reduced, so you don't have to do it at the very end. Okay, so what is 5 times 3? Well, that is 15. Okay, over 8. Okay, so that would be the answer. Okay, or if you want to convert this to a mixed number, then we take 15 and you figure out how many 8s go into it evenly. Well, 15 divided by 8 only goes in there 1 time, and that's the whole number 1. And then the fraction part, okay, if 15 goes into 8 once, right, then how many more to get to 15? Well, you can have 7 left over the original denominator. And that would be the answer for that. So I hope that, this video helps you with dealing with mixed numbers when it comes to order of operations, okay?